All right, so let's evaluate this determinant. All right, and again, remember, we're going to use our values here, here, and here, multiply them, and then we're going to use whatever our minors are to figure that out. So, first things first, minus 1. And then what's left over? Well, what left over is the 2 minus 3 and 6 and 9. Where's my, here it is, 2 minus 3, 6, 9. So that's going to be our minor. Then if we have 0 here, again, remember, it's a minus here. And then it's going to be a 3 minus 1, 6 minus 9. And then we have plus 2 times, then we have 3 minus 1, 2 minus 3. So now we just have to multiply those out. So that's going to be a minus 18 plus 18, so that gives us 0. And then 0 times, doesn't matter what that is, that's going to be 0. And then that's going to be a minus 9 plus 2, so it's going to be minus 7 times that. So we're just going to get a minus 14 for the determinant here. All right, now this one's a kind of a special thing. We're looking at a parcel of land, and if all units are in miles, we need to find the area of the parcel of land by using the determinant, okay? And so what we're going to do is we're going to choose one of the points as our first point, and then we're going to go basically uh, counterclockwise and put in our points. And our bottom row is going to be all ones. So what we do is we start down here. This is our first point. So we put our X and our Y. And then we're going to put 3, 1. Then we go over here, 6, 4. So it's going to be 6, 4. Then we're going to go up here, 4, 7. 4, 7. And then it's going to be 1, 1, 1 for our bottom row. And we're going to take half of that of whatever the determinant of this matrix is. Okay. And so what we need to do is we need to do like we've been doing. We're going to take what? 3 times the determinant of, now what's left over is a 4, a 7, and a 1, and a 1. Okay. Then we're going to take a minus 1 times the determinant. I should probably put determinant. And then we have a 6, 4, and then a 1, a 1. And then plus 1 times the determinant of 6, 4, and 4, 7. Okay, so that's what we're doing, and that's to get to this piece here. And then we're going to take half of whatever that is. So then I guess we could put all that in parentheses and say half of that. Okay, so 4 minus 7 is going to be what? Minus 3 times 3 is going to be minus 9. And then here we have 6 minus 4 is going to be 2, so that's going to be minus 2. And then we have here 42 plus 16. And so if we add all that together, it looks like 15, yeah. And so then we just have half of that. Half of that's going to be 7.5. We want the area, so it's going to be 7.5 square miles. Okay. And again, that's all we did is we broke this big determinant down a 3 by 3 into the what's inside of parentheses here, and we found that was 15, took half of it, and we get 7.5. What about Kramer's rule? Here we have a rule for us, and this is for linear systems and two variables. So the solution to this system of linear equations is given by, well, x is going to be e divided by d, and y is going to be f divided by d. Well, what are e, f, and d? Well, e is going to be the determinant c1, b1, c2, b2. Okay, so that's going to be the determinant. So again, we're going to put c1, c2 on the left, and then B1, B2 on the right. F is going to be A1, A2, and then C1, C2. So that's going to be our F. And D, that's just going to be A1, A2, B1, B2. So we're going to find all of those, and then we're just going to take whatever that determinant is, plug it in, here, 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 and that's going to give us the solution to this 2 by 2 fairly quickly. So what if we do this one here? Well, E is going to be the 7 minus 5 and minus 2, 2. And so we work that out and we get 4. Now F is going to be the 1, 1, 7 minus 5. So that's going to be minus 5 minus 7 is going to be minus 12. And our last one is going to be the 1 minus 2, 1, 2. And so that's going to be 2 minus 2 is going to be 4. Okay? So that is going to be our E, F, and D. And now we just have to plug those into the X and Y equations. So X, remember, is E over D. And so E is 4, D is 4, so that gives us 1. Y is going to be the F over D, so minus 12 over the 4, so that's going to give us minus 3. And so X1 y minus 3. And so that's going to be our ordered pair, and that's going to be our solution. Okay, so that's something really nice to be able to do 2 by 2. And again, is this more work than actually just doing the Gauss-Jordan reduction? Or, say, okay, well, if we just add these together, we get 2x is equal to 2, so x is 1, plug that back in and solve, and we get the -3. So, sometimes it's going to be easier maybe doing it this way. Sometimes it's easier maybe doing it just as a system of equations. Sometimes it's easier doing it as a matrix, depending on each person's going to have a different way they like to do it. And so this is just one example of ways to do this type of solution. All right, so that's what I have for this section. So hopefully that will help.